Hi, Kirti. Good afternoon.
Hi, ma'am. Good afternoon.
Yeah, hi. How are you?
Yeah, I'm doing good. Hope you're also doing good, ma'am.
Yeah, I'm doing good. Okay, shall we start?
Yes, ma'am. We can start.
Okay, please introduce yourself.
Sure. Yes, ma'am. So first of all, I'm immensely grateful for the opportunity that is provided here. I have already worked for 2 years after graduating in Tata Elxsi as a broadcast engineer under RDKV domain. But since I was interested to pursue my career in VLSI, I left and started with this training for the past 6 months. I got upskilled in digital logic design, then Verilog design and the verification concepts such as system Verilog, UVM, and also various protocols associated with it, which is used for the communication in the chips. So, though I am a fresher with respect to VLSI, I am experienced as an employee since I worked in a company already. I am very good in managing the tasks and completing it before the deadline and communicating with my teammates. So I possess a good communication skill, and hence I will be able to work in a good way in a team. I will be able to contribute much. So I hope I can incorporate the skills which I learned over the past 6 months with those skills as well and contribute in a much better way to this company, ma'am. Hoping for the best.
Oh, okay, Kirti.
Yes, ma'am.
Okay, how would you rate yourself in Verilog?
Uh, write myself.
Yeah, out of 10, how would you rate yourself in Verilog?
Okay. I might rate 8 out of 10, ma'am.
Okay, in system Verilog and UVM?
System Verilog also, I will rate 8. UVM, I'll rate little less, maybe 7.
Okay, that's
Because
good.
conceptually I'm good, but
Mm,
I haven't have had much of hands-on practice with the code. So 6 or 7.
okay, okay. Can you share your screen?
Sure, ma'am. Is my screen visible, ma'am?
Yeah, it's going to. Yeah, it's visible. You can open Notepad there.
Yeah.
So first we'll start with the system verilog. Okay.
Yes,
So
ma'am.
there are 10 number of test cases. So each
Okay.
test case generating some variables like address and data.
Okay.
So all test cases generating address is less than 50 and data is greater than 100 in first scenario.
Address is less than 50
50, data
and
is greater than 100
mm,
in first scenario. In
okay.
second case, address is generating greater than 50
Okay. Greater than
and
50.
data is generating less than 500.
500.
Yes.
Okay.
So first scenario we have verified. Okay. For address is less than 10, less than 50 and data is greater than 100. It is getting all scenarios correctly. So without changing the first scenario, how can how can we verify with the second scenario? Can you write the program using randomization and constraints?
Yes, ma'am. So first one, address less than 50 and data greater than 100, right, ma'am? Because I think
Yes,
I misheard something.
yes. Second scenario is also same, but we need not to change first scenario by taking the first scenario. Okay, we need to take second scenario without changing first case.
Ma'am, do I need to write the class or it is enough to just write the constraint statements and randomization statements?
You can write constraints. It's enough.
Okay, ma'am.
But if you write overall code, that is good practice in interview.
Okay, ma'am.
Simple way. Yeah.
Yeah. So yes, ma'am. So here, this is a global constraint. So I write this. This leads to. So first test case I have given as global constraint. At that time, I would not give the second constraint, ma'am. So with this constraint, the first case will run. So while giving second constraint, without changing this, I can just use inline constraint. So in the randomized statement itself, I can add the constraint conditions. Here, data is fine. Already data is greater than 100. So when I use it is less than 500, there is no conflict. But since the address is ending up with conflict, I can use soft here so that it will just implement this without any conflict.
Okay.
So this involves both inline constraint and soft constraint, ma'am.
Okay. Okay. Can you write a small code difference between deep copy and shallow copy?
Okay, ma'am. Yes, ma'am. Here, this is shallow copy. And here I'm just copying the reference of one of the object to the other object. Means the complete memory location of all the attributes. So whatever change is made is being reflected in the other object as well. Whereas in the deep copy, it is just copying the actual values. So when I later change the value of the original object, it is not reflected in the copied object, ma'am. So this is actually copying of the location, the reference. This is just copying the data, actual data.
Okay. Okay. So, what is the difference between mailbox and queue?
So mailbox is actually used for communication between generator and a driver in system verilog, ma'am. Both are actually similar in function only. In queue, it could be last in first out or first in first out. In mailbox, it's mostly like first in first out. But the main difference is mailbox can have either blocking or non-blocking methods, whereas queue is always non-blocking. For an example, in mailbox, we have methods like try, get, try, peek as non-blocking methods, as well as blocking methods like get, peek. So blocking means if there is already a process going on and the driver is busy, the next process, the driver will block. Until the previous process gets over, it will block it. Whereas in non-blocking, it won't care. So either the driver will accept or reject it, but the generator will keep on sending the data. So it is non-blocking. Whereas in queue, everything is non-blocking, ma'am.
Okay. Okay. So, next question. Suppose there are 20 number of commands.
Okay.
Okay, 20 commands. So each command doing some arithmetic logical operations or shifting or bitwise operations. Okay. Suppose command 0 is generating addition operation of two variables like data 1 and data 2.
Okay.
Okay,
Data
addition
one.
operation of data 1 and data 2.
Yes, ma'am.
And command 1 is subtraction.
Command one is subtraction.
Command 2 multiplication. Command
Yes,
3
ma'am.
division. Command 4 logical and. Command 5 logical or. Command 6 logical not. Command 7 bitwise. Command 8 conditional operator. Okay. So in
Right.
this,
Yes,
okay.
ma'am.
So in this, I want to do a multiplication operation and division operation and bitwise operation for data 1 and data 2.
Okay, ma'am. So
Okay.
multiplication, division, bitwise.
Yes. The requirement is only these three functionality. Okay. So I
Okay,
want to
ma'am.
do the randomization. That means how would you write the program to generate these three functionalities in verification?
Okay, ma'am. So you have given eight commands here, but it actually goes up to 20, right, ma'am? Or it
Yes,
ends with
yes,
8.
yes,
Okay,
yes, sir.
okay.
The needed functionality only three. So how can you generate only those three functionality?
Okay, ma'am. I think in previous question also I forgot to mention this rand variable somewhere here. Okay. So this would be my command now. So in my design, here I have declared a 4-bit, sorry, a 5-bit variable y. Since there are 20 commands, I have used a 5-bit variable. So in my design, for every 5-bit value, I would have assigned a particular operation, maybe using a case statement. So from here, I can randomize it by providing a constraint using the uh, inside block.
Okay. So, and the data one, data two must be generate between data one must generate between 100 to 200, and data two must generate multiples of
Wait,
5 between 200 to 300.
100 to 200,
Data 2
200
multiples of 5 between 200 to 300.
multiples of 5 between 200 to 300. Okay. So the first condition, data 1 ranges from 100 to 200. Data 2, it has to range from 200 to 300, but with the condition that it has to be multiples of 5. So I have just used a loop here, starting from 200 and ending with 300. So whichever value gets divided by 5, if it is a multiple of 5, then the remainder will be 0. So for this condition, the constraints, the samples will be generated now.
Okay. So I have shared a code snippet in the chat box. Can you open that first example?
Yes. First one, ma'am. Or
Yes.
which one? This one.
So
Yes, ma'am.
what is meant by that? What will be the output? What is the intention of the term code snippet?
We are actually randomizing the two variables data 1 and data 2, ma'am. So this is the class, and we have declared the variables here. Within the module, 5 times we are randomizing. So 5 times we will get different sets of data for data 1 and data 2. So it will be ranging from 0, since this is 4-bit, the value will be ranging from 0 to 15 for both data 1 and data 2. But I think here display, yeah, we need to give that percentage key, and also that the data will be printed.
Okay. Can you find any error in that program?
Yeah, initial begin syntax errors I can see, ma'am. For initial begin, we should not use the semicolon.
Okay.
Then repeat we should not use, and yeah, I think we have not created the object yet. We have just declared the object name. Here we need
Okay.
to create the object. Only if we give new, it will be created. So yeah,
Okay. Yeah.
and ma'am, and also randomize. The computer will accept only if it is ZT, right, ma'am, and not SC.
Yes.
Okay.
Okay. That's correct. Okay. So coming to Verilog, can you take second code snippet from the chat box?
Here, ma'am. This one, ma'am, time scale.
Yes.
Okay. So I need to provide outputs, right, ma'am? Okay. Data.
Yes.
Real time. 0.5. Yes. So this is real time. Yes, ma'am, this will be the output. So the first, the time scale it has taken for 10. So we will multiply by 10. This becomes 24.5, but the precision is for 1 nanosecond. So we'll approximate, round it off to 25. And here, if we multiply 10, it is 5. Here it is 50 and 16 times, 16 nanoseconds.
Okay. Okay. Coming to the UPM, what is the difference between sequence, sequencer, and sequence item?
Okay, ma'am. So sequencer is actually sequence items are the data items. They are the actual stimulus which are being generated, and that process is being done by sequence. So sequence will generate the sequence items, and the sequencer is like a router. It will just take the sequence items generated by the sequence to the driver.
Okay, that's it.
Yes, ma'am. And the one more main difference is that sequencer is actually a component, whereas sequence is not a component. Sequencer is a part of the UVM agent itself. The sequence itself can't directly access if there are multiple sequencers, like virtual sequencers within the sequencer. The sequence, unless it is a virtual sequence, it can't directly access all the other sequences. So, since sequencer is a
Okay.
component, that is one difference.
Okay. So in UVM, what is the need of RAL model? Where do we use RAL model, and what are the different components in RAL?
Yes, ma'am. So RAL stands for Register Abstraction Layer. It is basically used for testing and verifying that registers and memories within the DUT, ma'am. So we generally create stimulus and run for all the components. So this is specifically for the memory-based registers. So it has some standard class, predefined and pre-built class libraries, which makes it easy, and a specific set of registered data will be generated to make the work easy. So the basic components in a RAL model is the RAL database. So the RAL database will be holding few components within it. So it will have registers, the basic elements. Within registers, there will be register fields. These register fields will hold the register data, means the register sequence items. And then it will have memories and also a register map, which will map the register to the required location memories. And also there will be a register file. The register file will hold the multiple registers, ma'am. The register file can be either manually generated or can be generated using a tool. If it is going to be a simple test or only few data are there, then manually it can be generated. Means manually it can be created. Else, there are tools to generate it, and it will be available as packages. Okay, so this is the main component of that, and along with that we have adapter. So adapter is basically used to used in between the RAL and the UVM agent. The reason is that the UVM the register database will have the data as registers, right? Whereas the DUT and the UVM agent will be communicating through bus transactions. So to to convert the register transactions to the bus transactions, we use adapter in between the RAL model and the UVM agent. So it will be connected to the database on one end and to the sequencer on the other end. Then we have predictor. So predictor, the main functionality is that to update the data that is generated from the hardware registers in the DUT to the register database. In register database, there are two important fields. One is one holds the desired value and another holds the mirror value. So desired value is something which is expected as a result. Mirror value is the actual data which is generated. Two fields. One holds the desired value and another holds the mirror value. So desired value is the expected value. Mirror value will hold the actual data which is generated by the DUT during the test. So predictor will update the values based on the DUT in the database to compare them. So the predictor will also have an adapter, because actually in RAL there are two types of access. One is front door access and another back door access. In front door access, it goes through the UVM agent through the interface and then DUT, whereas in backdoor access, it directly communicates with DUT. So here also, the DUT will be working only with the bits binary, right? So it has to convert the bus transaction to the register transaction. So again, along with the predictor, there will be an adapter. So yes, ma'am. So this is the main functioning of RAL model.
Okay, okay, that's fine. So in system Verilog, we use a new method to create the component or object, right? So
Yes, ma'am.
why we use create method in UVM?
Okay. So new method when we use, it will every time we use a new method, it will create separate memory. Okay. Whereas create, it can reuse the same memory. Means it allows us to override the data types, which is not allowed in the system Verilog new method. So create method is simply used for overriding the data types.
Okay. Okay. So what are the different callbacks in UVM?
Okay, so in UVM we have the main function that does the process is the body, the randomization. So we have pre-body and post-body as callbacks in UVM.
Okay. So have you worked on coverage, functional
Yes,
coverage and code coverage? Okay.
yeah,
So where
functional
do we
coverage is
use functional coverage and where do we use code coverage?
okay. So in code, we have design as well as test cases. So design we do with Verilog, right? So in design, if we have to check if all the numbers, if all the lines, statements which we have given are executed, all the functions like always block or all the conditional operators. So it just checks if all the data provided under design is tested. So that is code coverage. Functional coverage, it will verify if all the cases like the test cases are done, because that use if the device is going to perform multiple operations, then there will be multiple constraints, multiple randomization. So to handle that, we will provide multiple kinds of data, right? So it will check what type of inputs need to be tested and what type of inputs need to be rejected. So based on that, we have multiple types of coverage, ma'am. Using the coverage bins, we can actually design accordingly to check for a specific set of data.
Okay. So how can we achieve 100% coverage in real time?
First, we can run the test case with whatever we have given, and we can check if there is any holes. Means we have to first give a statement, ma'am. Option dot per instance equal to 1. If we give this, then if we give this statement and run the coverage, then it will show if all the bins are hitted, if anything is missed, if there is any holes found. So we need to pick the missed bin, and we need to make changes accordingly to add the missed input as well, and then we can rerun so that we can get 100% coverage, so that all functionality of the design is tested.
Okay. Okay. Suppose there are 100 number of test cases. Okay. So in 100 number of test cases, each functionality is meeting 5% coverage. Okay. For every regression or every coverage upload, 5% is increasing. Okay. Still, to reach 100%, there is 22% coverage still left. Okay. All test cases are completed. Mean all test cases are passed. Okay. Coverage also hit at for the test cases. Okay, so still, how can we reach 100% coverage? Still, bins are there, even test cases are passed, and functionality is meeting. Still, bins are left for the test cases. So, how can we reach 100%?
Uh, okay. So the main functionality that it was designed is tested completely, but the percentage has not yet strike to 100%. That's what you're asking, right, ma'am?
Yes.
Okay. We can use ignore bins, ma'am. So those bins which are not covered and which are not required to be covered, we can use ignore in front of those bins so that they will be ignored whenever they are generated. So that it will also be taken under consideration for the percentage, coverage percentage.
Okay. Okay. So, have you worked on assertion in system-wide logs?
Uh, yes, ma'am. Yeah, conceptually, I'm good. I'm okay with it, but haven't had any hands-on or code experience
Okay.
with it, ma'am.
Okay. What is the difference between immediate assertion and concurrent assertion?
So immediate assertion means it happens in a single clock cycle. In one clock cycle itself, the process will get over. Whereas concurrent means it will take multiple clock cycles to perform a particular task.
Okay, Kirti, I'm done for today. In second round, we'll discuss on protocols and projects. Okay.
Okay, ma'am.
Okay. Okay. So, can you tell me what projects you have worked on?
Yeah, I have worked on two projects, ma'am. One is 4-port calculator, and one more is the router project.
Okay. So, protocols.
Protocols, I have idea on UART protocol, I2C protocol, and the basic AMBA protocols like APB, AHP, and AXI, and also that AHP to APB bridge map.
Okay. Okay. So, okay. Can you share your screen?
Yes, ma'am.
Just a second. Okay. You can share now. So, how you have implemented UART?
Uh, is my screen visible, ma'am?
No.
No, I have stopped sharing. Okay. Now it's visible, ma'am.
Yes.
Okay. Should I open anything like a notepad and all?
If you want to draw, you can open. Otherwise,
Yes, ma'am.
okay, just open
Yeah.
Notepad.
Okay, fine. Yes, ma'am. So UART protocol is actually a universal asynchronous receiver and transmitter protocol, right? So it is basically going to communicate the data in a serial manner. So we will have a transmitter and also a receiver. There will be two wires, one to transmit and another to receive. But it is a half duplex protocol, means at that time, only one direction communication is allowed. Okay, so here we have two, right? One is transmitter, another is receiver. So at the transmitter end, we will have four components, and similarly at the receiver end we have some four components. So as I already said, the data will be in, before it comes into this UART, it will be in a parallel way, right? So it has to be first converted into serial data. The parallel data has to be converted to serial data inside the transmitter, and once the data is transmitted at the receiver end, it will be converted back to a parallel data. So for that we will need a shift register, a parallel and serial shift register in the transmitter. Then we will have multiplexer in order to combine data. So basically, so in what way the data will be transferred is, first we will have a start bit, then followed by that we will have 8-bit data, then we will have a parity bit and a stop bit. So here, how the transmitter will receive the will detect the data that is sent is, it will look for, it will be high, it will be continuously high. So it will look for the start bit. The start bit has to be 0. So if the 0 is detected, it means the data is transmitted. So followed by that, the LSB of the serial data is sent first. Okay, so from 0 to 7, the bits will follow. And as after these 8 bits, there will be a parity bit that will be generated based on some reduction operation in that particular data bit. So for that, we will have a parity generator also. So after that, it will send a stop bit. Stop bit will be 1. So start bit is 0, stop bit will be 1. So after detecting that 1, the receiver will recognize that the packet is done. Okay, so this is the basic packet information, data information. So for this, what are all components is required on the transmitter end is, as I already said, we need a shift register to convert the parallel data to serial data. Then to add the start bit and parity bit and the stop bit, we need a mux. Either we can have a mux or we can directly, I think we can also use a P4. Initially, we can send the start bit, followed by that we can put the data after it comes out of the register. Then we can insert the parity bit and then stop bit. I think anything can be used here. So we can also use a mux. And also a state controller mission, FSM. So in order to coordinate and control the sequence of operations, like first which data has to go, second which data has to go, for that we can use an FSM. And also a parity generator. So these are the components used in the transmitter end. In the receiver end, similarly, we need to have a demux to get all the data separated. That is, once it detects the start bit, it will take the start bit first, then it will get the 7-bit data. It will do a parity checking. There in the transmitter end, it is parity generation. In the receiver end, it is parity checking. And once stop bit is detected, it will take the data and convert it into parallel data. So for that, it needs a serial in parallel out shift register. Similarly, there also we will have a FSM to control the sequence in which the operation has to be done. And here, one more important thing is the only protocol which works in an asynchronous way is UART, which means it doesn't have a common clock. Instead of that, there will be internal clocks for both transmitter and receiver. Both are running at a different clock frequency. So in order to guide the data by having both the clock frequency, the data is received in this UART receiver. Yes, ma'am. This is the basic functionality of UART.
Okay. So what is the maximum data rate you have used in UART?
I think 11,000, 1,15,200. That is
Okay.
the maximum I'm aware of, ma'am. I'm not sure if there is anything higher to that.
Okay. Okay. So, okay. So have you worked on AXI protocol?
Yes, ma'am. AXI protocol, I haven't implemented it code, but yeah, I have the idea of how it works.
Okay. So what is the difference between APB, AHB, and AXI?
The basic difference is the bandwidth. Actually, APB works for low bandwidth. We have in a chip, we will be having the memories internally, the microcontroller, basic microcontroller. We will also have some peripheral IPs and the other peripherals which will be out of the chip. So in order to communicate between these high performance devices and with those peripherals, we will be using this APB. APB is basically used only for the low bandwidth IPs. So low performance operation, it will be used. AXI, a little higher performance. So AHB stands for that. AHB is AMBA high performance bus. Then AXI is extensible interface. So it provides much more higher bandwidth and higher performance, ma'am. There is a unique feature with AHB and AXA when compared to APB. APB is basically used only for smaller operations, right? Whereas AHB provides burst operations, burst transfers, split transfers, and others. And also the data width that can be shared or transmitted is higher when compared to APB. APB, I think it allows only 32 bit at max, whereas AHB, it can go to 64 or 128 bit also, and AXA also same. So, AXA is an advanced version of AHB with a very high performance.
Okay. In AHP protocol, there will be wait state and without wait state, right? So
Yes,
with which signal we will compare that, and what
yeah,
is the difference between these two? Can you draw the waveform with respect to
wait,
the address, data, clock, reset, and whatever the APB signals are there remaining?
okay.
Please draw comparison diagram. Yeah.
For AHB right now, okay, AHB.
Yes. With
So I will
wait state and without wait state.
okay. So we will have shall I go with read mode, ma'am? Read or write mode you want?
Anyone fine.
Okay. So in AHB, for example, let us consider it is performing some write operation. So we have H address. Okay, so this will be sent from the master. We will be having some address byte here. So when address is available, and if it wants to write the data, H write will be 1. We will have let's say this is H write. H right. I'm using short forms, ma'am. Please ignore because my mouse pad is little slow.
It's okay.
I'm not.
No problem.
Yeah.
You
So
can just tell and you can draw waveform. No need to write.
okay, ma'am. So this is H right. So if it is going to write, the H right should be high. If it is in read mode, it should be low. So here I'm making it high, and H address is available. And similarly, we will have the HW data. So HW data will also be available. So in this condition, the receiver, the AHB slave has to receive this data. It will check if it is already processing the previous transaction and it is busy currently, it won't be able to process the upcoming transaction. So at that time, it will, due to the busy state, it will not show H ready high. Means H ready will remain low. Only when H ready turns high, for example, let's say it is low until this period, so it won't take the data, means HRD is still low. So this packet availability will extend till the HRD is high. So once HRD turns high, only then the data will be sampled, means the HW data will be sampled by the slave. So though that period of extension of the packet, right, so that is called the wait state actually. But if the moment in the clock in which the address is sent, if the slave is ready to accept it at the same clock itself, then there is no wait. Actually, it won't occur in the same clock. It will take 2 cycles because since this is pipeline, address phase will come first, then data phase will come second. But it won't wait. It won't have the HRD low. As soon as the data is available, HRD will turn high. So that is a no wait statement.
Okay. Okay. Next question. So AHP is a pipeline, right? So how do you implement pipeline architecture in AHP?
Pipeline architecture in the sense, first it will be in idle state. Then it has to check for the packet availability. So once the data is available, it will initiate the transaction. So next it will go to address phase. From idle phase, once the address is detected, then it will get the address. So that will be called as the address phase. So only after the address is detected, the slave will send ready. So after that only it will enter into data phase. So the reason the pipeline architecture is advantages is that the data won't come. Even if the data comes ahead of that particular address, the receiver can easily recognize like which this data matches to which address. So that's why it has the pipeline architecture now.
Okay. Okay. And what is meant by bokeh response, split response in AHP?
Okay, response means, okay, so response is provided by the receiver always. Means if, for example, if you are taking write mode, the master will be sending the address first, then it will give the the data that is to be written into the slave. Once the slave is ready, it will accept the data, and if the slave receives the complete data without any issues, if there is no loss in data, it will send an okay response indicating that the transaction is successful. So this is okay response. Error means if there is any loss in data, it hasn't reached properly, or maybe for a long duration of time, the slave is busy and it's not able to read the data, then it will send error, indicating that the transaction has failed.
Okay. What
And
about
also
split and retry?
split and retry is like here in AHB supports multi-master, multi-slave conference. So arbitration comes into play here. So if the slave detects that a particular transaction will take so much of time and there are pending priority transactions that has to take place, what it will do is it will provide split as a response. So what the arbiter will do is it will just provide a dummy master to that particular slave and makes use of the other priority task to complete first. So further it will give the split. So once all the other priority tasks get over, or in case that particular slave is now ready to accept the data, in that case it will ask for a retry. So split and retry will work in this way. Split is to just cut off that master from slave, and retry is just and going back to that particular master again to retry that particular transaction to that slave.
Okay. So in AXI, there is a concept of out of order transaction, right? So what do you mean that?
Out of order transactions, I think if the data is not in sequence, if the data that is one data will have a huge size, it will take too long to send. Some data will go fast, it will reach fast. So the sent order and the received order might be different. So in that case, an ID will be an identification tag will be given. That is one of the unique feature of AXI, which is not seen in AHB and APB. So based on those ID tags, it can recognize in which order it has to be sent. The data which belongs to a particular sequence will have same ID, which means they are in order transactions. If they don't belong to that particular sequence of data, different IDs will be given. So based on that ID value, it will recognize which data it belongs to. So even if it reaches, because in AXI we have separate address and data lanes, even for both read and write. For write, I think we have 3 channels, and for read we have 2 channels. So totally there are 5 channels. So it is not mandatory that the same order, in whichever order it is sent, it is not necessary that in the same order it has to be received. So if it goes out of order, the ID tags are used to recognize them.
Okay. So what is mean by burst transaction? What are different burst transfers we have?
Okay. Yes, ma'am. Burst transactions are sending multiple sets of data at a time rather than sending a data byte by byte. Actually, here the transaction happens by byte. So rather than sending it and checking for every byte, they consolidate all the or a set of data bytes as beats. Okay, and maybe it could be 4-bit or 8-bit or 16-bit. So they will combine them together and send it as one burst. So in each burst, there could be, as I already said, there could be 4 bits, 8 bits, or 16 bits, and in each bit there will be multiple datas. That is in the form of bytes. There could be 4-byte data or 10 or anything like that. So for that, we have few signals to determine the data size and the burst size. So H burst will determine in HB, H burst will determine what type of burst it is. Like is it an incrementing burst or a wrapping burst, or how much size, 4-bit or 8-bit or 16-bit. Similarly, we have H size signal to determine what is the data width which is sent within the burst. So it could range from 8 to 1024 bits. Maybe they will be in the form of bytes. So I think it will be 1 to 128 bytes.
Okay. So coming to the I2C protocol, you have worked on I2C protocol, right?
Yes, ma'am. I
So
have
what are the
gone through
interfaces? What are the interfaces in I2C?
interfaces. Oh no, ma'am, I'm not aware of that interfaces.
Like interface signals, serial interface signals in
Yeah, the
I2C.
signals we have a serial data line and serial clock line.
Okay. Okay.
So,
Yes, tell.
yeah, should I explain how how those signals work, ma'am?
No need. So
Yeah.
if there are multiple number of masters, how a master can run the bus?
Okay, here there will be an arbitration concept, ma'am, based on um, the the frame format of the data that is being sent by the master. So the clock line. So when it will determine the data is being sent is that when the clock line is high and the data line goes low, it means there is a frame transmission happening. So based on that, the bus will identify which master is sending that. So which master's data line is going low when the clock signal is high. So based on that, it will provide the bus. And first the address will be transferred and then the data.
Okay. So how you will write the design for that condition in Verilog?
We can go with the check conditional operators also, ma'am, either using if else or directly conditional operator here, because in only 2 cases means if the clock is actually the data should not vary. The data which is present in the data line should not vary if the clock is high. So we can use conditions like if the clock line is high and the data line switches from high to low, then in that case start maybe we can say the first phase, first state as start state. Then sequentially it has to get the address. So once the data transmission starts, it will get an address. Maybe we can use a register or a FIFO to store. Since it is a serial, I think we can use FIFO to store the data. Then once we can count, see the address that is shared should be 7-bit length. So we can use a counter to check how many number of bytes, how many number of bits are transmitted once the transaction has started. So once the count reaches 7, then we have to check for the read or write bit. So if it is read bit, then we can have a separate logic to read, and write we can have separate logic to write. And after that, after the 8 bits are reached, it has to get some acknowledgement. So we can provide an acknowledgement bit from the slave end. And for write and read, we can say who is the sender and who is. So for the read case, we can take the data memory from slave and the data from the memory enclave to the sender, that is to the master. In write case, we can take the data that is stored in the memory of master to the memory of slave.
Okay.
So by using the sequence conditions, we can do.
Okay, fine. So what is meant by clock stretching concept in I2C?
Actually, clocks in I2C, I'm not aware, ma'am. But generally, clock stretching is nothing but frequency division. So sometimes the data won't be available, or sometimes the data that is received might not be stable. So in order to provide it some time to receive the data, either if it is delayed or if it is not stable, we will be extending that clock length. So that is the purpose for which we do the clock stretching or frequency division.
Okay. So have you done any coverage analysis of these protocols for UART or
No,
I2C or APB?
no, ma'am. Coverage I haven't done.
Okay. Or assertion? Have you done assertion verification?
No, ma'am.
Okay. So next, you have worked on router projects, right?
Yes, ma'am.
Okay. So what type of router it is?
One input and 3-port output router.
Okay. Okay. Have you designed or verified?
I am halfway through it, ma'am. I have only designed the 3 components and I'm yet to decide that state machine. So
Okay.
we have that register and the synchronize and others, right? That FIFOs and those 3 components I have designed, but I still have FSM pending.
Okay. 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 I will just ask you one logical question.
Okay, ma'am.
Suppose there is a series
Okay.
2 1
2 1
3 2
D 2
3 3 2
D 3.
1 2 1 3 2
Oh,
TH
3
or
2
E 3 2
3 2
4 3.
4 3.
What is the next series?
So, like, are these separate digits, ma'am, or these it is like a single
Separate
data?
digits.
Okay, 2, comma 1, comma 3,
Yes.
comma 2, comma 4, comma 3.
Yes.
Hmm. Is it 2, comma 7, comma 3, ma'am?
2 1 3 2 4 3. What is the next series?
2 1 3 2 4 3. I think it should be 2. Or can you share
Okay.
me that question in the chat, ma'am? Because I'm not sure like how that series looks like.
See, series means like whatever you have written. Can you write again? 2.
I'll use a text box. Where is the text box?
See here A. Click on A
Yeah.
near brush. You can maximize the screen.
2, comma 1,
2 space 1 space 3 comma
okay,
2 4 3.
3.
Next, what is the next value?
Uh, Is it like by relating with this digital design, or it
Yes,
is a simple?
yes,
Okay,
you can relate before values, and you can tell what is the next value. Like we got
okay,
2, 1, 3. After 2 we got. So how we got that 2? Next 4 we got.
okay,
How we got that 4? Like that. What is
okay,
the
ma'am.
next?
0, 0, 0, 0, 0, um, 1, 0, 0, 0, 1, 1. Zero, zero,
No need to convert into binary. You can do normal calculation.
okay. Normal calculation means simple max, like you are like
Yes,
that you are saying analytically.
yes.
Okay. This -1 +2 -1 +2 -1 +2 5, ma'am.
Okay. Is that confirmed?
I hope so because when I follow the sequence, 2 minus 1 is 1 +2 3 -1 2 +2 4 -1 3 +2 5. By this logic, this must be correct, ma'am.
Okay. Next question.
Yes.
What is the probability of rolling a die and getting a multiple of 3?
Multiple of 3. So dice has like 1, 9. Okay. So 3, 6, 9. Probabilities. In a single throw, ma'am. Hello.
Hello. Yeah, yeah.
In a
Yes, sir.
single throw, you are
In
asking for the probability.
Not in a single throw, like whatever the possible outcome, in 6 throws, 6 times.
Yes. So 1 plus 7, 9. So 1 by 3, 1 by 3 into 2. So 3 6 times. This was 6. 3 and 6. So this be 1. Oh, 6. So in all the 6 cases, just like 1 by 3. This should be multiplication. So this 1, 2 and 6 times. And 6 plus Probability of 0.3, ma'am.
Okay. For 6 times, you are rolling it die.
I'm not sure if this is for 6 time or 1 time. Even if I calculate for 6 times, I get it as 1.3 only, ma'am.
Okay. Okay. So one last question. So
Okay.
if you get the role as a senior design verification engineer, so how you will overcome the challenges? What are the challenges you are going to face? Okay. And how you will collaborate with your team and team leader? Can you brief yourself?
Okay, if I'm getting placed as a design verification engineer, ma'am.
Yes.
Yeah, so I don't think it will be really difficult for me to get mingled with the team, because I already have that experience of working with different teams. In my previous jobs, I worked in 2 projects. So in both the projects, I had opportunity to interact with different teams. Especially in the last project which I did, I had to attend too many meetings, and I had to interact with many senior people, not just from my company, but the other partner companies and across uh, the global companies. So it was very new experience. Even though I was unprepared then, it actually boosted my confidence also. I was able to take up tasks myself from uh, different kinds of people. I used to interact with customers directly to get their queries and get them sorted out. So these things I think are very important for an employee. Since I think I'm eligible to do that, it won't be much difficult. But the only thing which I face difficulty, I believe, is that uh, this domain is new for me. Though I have had some good knowledge on Verilog, system Verilog, and UVM, and all the design and verification concepts, I'm still yet to get an hands-on experience on the real industry level projects. So I think it will be the only challenging thing for me. Initially, it might take some time to grasp those things, because only when we enter into a project will we get the basic idea of what is happening. So once I get to know about that, I think nothing is going to be a hurdle.
Okay, fine. Okay,
Yes.
I'm done, Kirti. So do you have any questions to ask for me?
No, ma'am. I just want to get some data on I2C. Actually, I don't have notes for I2C. I learned it from internet. So can you please share me if you have some PDF notes on on the complete working of I2C, ma'am? Like how we
Okay.
have some PDFs for AHP, AXI, and all.
Yes, yes. Okay, okay. Sure.
Okay.
Do you have any questions other than that your interview performance, like, or
Sure,
any
ma'am.
other
It will be
inter?
good if you could give me some feedback and where I have to improve and all.
Yes, yes. I will share your feedback.
Okay, ma'am.
Okay. Yeah. Okay
Yes, ma'am.
then.
Ma'am,
Bye.
and